This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
Before we begin today's show, we want to thank our sponsor again, Rollbar. Rollbar is amazing. We have told you this for a couple of weeks now. Last week, I told you about their awesome curl replay command feature. This week, I want to give you another tip. It's a slightly different one. Sometimes it's nice to add warnings or reminders right in your code because, the code is the ultimate source of truth. If you work at a big team and you have a constantly changing environment, it's natural sometimes to just want to change an API, but you can't just remove it from your backend because there are old clients still using that API and you have to wait for them to upgrade. And then eventually when all of them upgrade, you can finally remove that endpoint, but then you need someone who remembers to remove or delete that code with that change. Machines should be taking care of this. I always believe that the machines are supposed to be doing our work. Now, your adoption cycle may vary, but sometimes you have an idea of how quickly folks upgrade your app version. And so it would be nice to, get a gentle nudge or reminder to clean up shop 6 months from now. Because otherwise your backend code will just start ballooning into this mess. With Rollbar, you can log a custom warning or even a custom log in your code, say 6 months from now. Throw a warning or an error saying, hey, whoever's dealing with the code now, make sure you delete this swath of code if no one's using it. It's almost like a hacky, poor man's API versioning, but hey, it totally works. And in this way, Rollbar also helps you keep your code base clean. If there's like a weird bug that's happening and it's happening at a particular point in the code, like, if some object is null for some reason when it's not supposed to be, then you can quickly use Rollbar and log an exception there, because then you have the complete trace of how the API endpoint was called, with what parameters it was sent from the client. In this way, Rollbar is super flexible and it allows you to really add all the right levels of diagnostics that you need to sort of detect, diagnose, and eliminate all these errors that you have in place. Trust me, this is just one of the many, many amazing things you can do with Rollbar. We use it at Instacart all the time. Sometimes you start to use a service and you can't imagine life without it. Rollbar is one of them. If you want to try it out, and I warn you, if you try it out, you're going to love the service. As part of a special offer for our listeners, they're giving their Bootstrap plan free for 90 days. That's 300,000 errors tracked for free. Make sure to use our special link, rollbar.com/fragmented, and they'll know you came from us. And it'll help support the show. With Rollbar, you put errors in their place, and you have a happy, clean code base. Thanks again to Rollbar for sponsoring this show. We're so happy to have them as sponsors.
So Kaushik, you're in a real studio right now, is that right?
I am. This is my first time where I'm in the amazing studios of Spec, and I have a guest with me, but we'll get to that shortly.
So how is the studio? You like it?
This is amazing. This studio is amazing. Actually, what I should do is take a picture and send it over to you. I know you're also trying to build your studio, so you should probably use this as sort of like a yardstick.
Use reference material?
Yeah.
So what are we going to talk about today?
Okay, so you remember in our last I.O. episode, I went around asking people, hey, what are 3 libraries that you use? Mm-hmm. And almost unanimously, everyone chose Retrofit, right? So they chose Retrofit, and then interchangeably, they kept saying okHttp.
Mm-hmm, totally.
And I sort of wanted to ask the question, because I know in the past, people have asked me, and people don't exactly understand what the difference is between okHttp and Retrofit and how it came about. And now there's also this thing called okIO from the folks at Square. A lot of cool stuff. These guys and gals are pretty smart. So clearly there's something. And if there are 4 or 5 of those libraries, clearly there's a reason why all of them exist. So we thought, why not just hop in and, knock on the doors of Square and try to ask someone, hey, what's the deal with all these libraries? So we did. And one of the fine folks from Square actually responded. So we have our good friend, Jesse Wilson, with us.
Hello.
Welcome to the show.
Thank you.
So Jesse, for those of you who maybe are not familiar with you and listeners who are just new to the show, can you explain your background, who you are, where you work, what you've done in Android, and how long you've been involved in Android in itself?
Yeah, sure. So I started at Google through a happy accident in 2006. And shortly thereafter, I got to work with a guy named Bob Lee, who's also known as crazybob. Him and I were working on the AdWords front-end service in 2006 together. And he went off around 2007 or so to go join the Android project. And at the time, it was like super secret at Google. I don't know if they even like really called it Android. It was just like the Open Handset Alliance project, something. Mm-hmm. And they were off in like some secret secluded building. And so he'd gone off to Android, and that left me to sort of keep Juice running, because we were using Juice, and we'd actually built Juice for the AdWords front-end project at Google.
So what is Juice for those who are not familiar?
Juice is, and I should say it's Juice pronounced, it's spelled Guice if you're Googling it. Mm-hmm. So it's Juice, and it's pronounced like GIF. So Juice is a dependency injector. It's like it's a predecessor to Dagger, you could say.
Okay.
Uh-huh.
And actually, it was sort of a reaction to the Spring framework when Bob created it in 2006, if you want to get all retro. So anyway, I was working with Bob a little bit still on Juice, because he was sort of him and a guy named Kevin Brillian were the Juice leaders. And I was just a guy using it, and I had a lot of opinions because I wanted to make it better for AdWords. And so him and I got to become friends, and he said, hey, you should come work on Android with me. And so in, I think 2008, I joined Android just as they were launching. I think I started right before Cupcake launched. Mm-hmm. So this is very, very early days at Google, Android 1.5.
Wow.
And at the time, it seemed like Android was mostly done, right? It's like, okay, we have our core Java libraries, everything works, all the moving parts are there. And so, all we have to do is just polish this thing a little bit. And so I spent the next couple years working at Google, and it was wonderful. And I got involved in a handful of different projects to keep the Java.star libraries. So we called it libcore, and it was the same team as the Dalvik team. Mm-hmm. So I was working on like everything from string.java and arraylist.java up through to being like the crypto libraries and the XML parser and the JSON parser, and HTTP URL connection was also a thing I was responsible for.
Uh-huh.
So that was a fantastic opportunity. Can you imagine a better opportunity as an Android developer than to be there and to work on the core stuff? But life moves on, and me and my wife moved to Waterloo. And at the time, Bob, who got me started on Android, had moved to become the first CTO at Square. And so I'm in Waterloo and he's at Square, and every time Bob comes knocking, it's really hard to resist. He's a very compelling storyteller. So he convinced me to start Square's Waterloo office. And so for the first year or so of 2012, I guess is by then, it was me and a handful of people working out of my basement in Square in Waterloo. And we were the sort of like Waterloo problem-solving team where we went out and tried to build, utilities and things for various Square projects that needed Android support. And so that's where Dagger was born. We were using Juice actually in Square Register for Android, because Juice was, a thing that Bob had built, and Bob was working on Register, so Juice was there. And it was wonderful, except that it was really slow. And so my first project at Square was to come up with something that worked like Juice, but that was, solved a bunch of Juice's problems. So we built Dagger, and that was a lot of fun. And we collaborated on Dagger from the very beginning with some people at Google in Waterloo. And they ended up taking it over to do Dagger 2. So we won't talk too much about Dagger today. And then from there, I went on to do Square Cache. And I'm a little bit embarrassed and a little bit ashamed to say it, but since 2013, I've been a server developer who's been pretending to be an Android developer. If you're working at Square and, the server project is the thing that needs the most attention, sometimes you just have to do the work that needs doing.
Jesse, I'm pretty sure if you ask anyone around, they'll forgive you for that.
Okay. So,
given your contributions.
So, yeah. And then I guess the most recent part of the timeline of all of that is that shortly after I joined the cache team, Jake joined the cache team. And that's just been completely wonderful for me because it means that whenever we want to do some open source thing, it's just like him and I work on the same team and we can get lots done. And I've been really, really lucky to have him to like do code reviews and stuff. So we got to make a lot of good progress on okHttp, basically because I've been able to have him being a second set of eyes on everything.
I have to ask the most important question, like in this whole episode. I think this is basically the most important question. What does the OK stand for?
Oh, wow.
Because there's okHttp, there's okIO. I've tried to look, and I know Square is pretty coy and intelligent with some of the names that they come up with for their library, so I'm dying to know this.
So I'll give you a little bit of background as to why okHttp even exists, and then I'll answer your question.
Okay.
When I was working on HTTP URL connection and things at Google in 2008, 2009, I met with a guy from the Chrome team named Roberto Pion, and he was working on this weird new project called Speedy.
Oh.
And so him and I are talking about Speedy, and the Chrome team is just like an amazingly productive team at Google. And we're the Android team, and we're like the scrappy team. They're like the special, most loved son of Google, and we're like the rebellious teenager who's like always getting into trouble and doesn't do things by the rules. So he was saying, Android should do Speedy, and I like made this sort of like, promise to him, commitment. I said, oh yeah, we'll like get Speedy working on Android. It shouldn't be that big of a deal. And so I started working on it, and it turns out that doing Speedy is very, very complicated in terms of making it work on Android for a handful of reasons, mostly to do with the way that the threading model is different. So I did my own little internal fork of HTTP URL connection, and I basically said this fork is just going to be where we do the Speedy support. And so for a while, there was a project on Google Code called Google okHttp. And this was never really public or released or anything, but this was like the very first version of okHttp was just a different version of HTTP URL connection that had a Speedy backend as well as the HTTP 1.1 backend. When you do your HTTP response codes, your 404 not found. If I say the numbers, you can like guess the codes. It's like 503, service not available, right. 400 bad request, and our favorite, of course, is 200 OK.
Yeah.
So when everything is working, it's okay. And so okHttp is me looking for words from the HTTP dictionary and finding the one that's like the happiest thing that something can be in HTTP is okay.
Oh, wow. Makes a lot of sense now that I think about it. Yeah.
That's cool. I like that.
See, I knew you guys had some good reason behind it.
Yeah. And then once you know that, then, and because I've been involved in this project a lot, you go in and you research like where does actually OK come from? And that's just like a completely ridiculous story where OK is like this word that we use all the time. And the as far as I know, the word origin of OK is a joke where in early 20th century newspapers, they would say, this is all correct. OLLKORRECT, all correct. It's okay. And so okay means all correct when you spell all correct terribly.
Oh, okay.
Yeah.
Okay. Okay. Yeah.
Yeah.
I'm not going to forget that.
Yeah.
Nice. So you mentioned some time back about HTTP URL connection, right? And so this is interesting because at this point, I guess all of us use okHttp and Retrofit so much that I actually forgot some of the native existing HTTP clients, right? So in Android, and this is also additionally interesting because one of the blog posts that you wrote some time back, and this was when you were at Google, I imagine, is where you introduced okHttp.
Kind of.
And you sort of like mentioned why it came about. So could you tell us a little more about that?
Yeah. So
because the native clients on Android, the native HTTP clients on Android, at least there were two at the time, right? There was Apache's HTTP client, and then there was HTTP URL connection. So could you like throw some light on that as well? Yeah.
So we the Android team, we made some like sort of structural mistakes early on.
No.
And this is too bad. You can, if you look at all your old Android APIs, you can see that some of them are like a little bit crufty. There are some mistakes in there. And one of the early mistakes that we made with Android was we said, okay, we need an HTTP client that's really good. And in 2006, Apache HTTP client was it was the best HTTP client you could get. And so we just took all of the Apache HTTP client code and we imported it into Android just as is. And so that was a good solution, but the Apache HTTP client is a very powerful, very flexible piece of software that is a very large API. We'd made lots of mistakes in bringing that API into Android, including we imported all the implementation detail internal packages as public APIs in Android. So when you're doing your Android app in 2006, you have the ability, though you shouldn't, you have the ability to like customize how it parses cookies or to customize all these other like tiny implementation details. And generally Android developers don't want to do this because, it's really low level things. But they mean that it was very difficult for us to make forward progress on the on the Apache HTTP implementation because we want to fix some bug or something. But because the API is just gigantic, mostly our fault, fixing anything has big consequences.
Came with a big cost as well, I imagine.
And the other side of that is that it means that if we're running, if you're running Cupcake or Donut, you're using Apache HTTP 4.1. And if we were to like follow this track, if you were using, Eclair, it would be 4.2. And if you're using Gingerbread, it'd be 4.3. And so we would have a big problem where if you were testing your Android apps, we would have to make sure that you tested every single HTTP client version.
Oh, wow.
Because the Apache HTTP client people were great and they did a good job of like maintaining forwards and backwards compatibility. But Android developers aren't used to, you use this API and it's slightly different implementations. Even like bug fixes can cause big problems and things like this.
Oh, for sure. I imagine.
So, and like when you're writing an application, you get to say, okay, we're going to ship our application with this version of Apache HTTP. And in general, like it was designed for the application developer to have control over the version.
Right.
But when we released it as a part of the core platform, we lost the ability to version it properly.
It limited your freedom in sort of like expanding that.
Yeah. And so basically at the time of that blog post, I think it was like 2011 or 2012, I made the call that we weren't going to be able to bring the features that we wanted to bring to HTTP on Android through the Apache HTTP client API just because it was so flexible and because we basically like ruined the API for ourselves. So we weren't going to be able to build Speedy on it. We weren't going to be able to build transparent gzip on it. And there were a handful of other features that we wanted to do to make HTTP faster and more reliable that just seemed really difficult to do there. So I wrote this blog post and I said like Apache HTTP client, it's great. It was the best client that we had, but it's not where we're going to put our future maintenance.
Okay.
And basically trying to like apologize to the Apache folks who'd been maintaining it because like we basically took their project and gave it a bad reputation because the version that we shipped was just like some random snapshot.
Oh, interesting.
Yeah. So that's a pretty long story.
Wow, that's very interesting.
Yeah, that's super interesting. And like you also mentioned some time back, right? Like part of the challenge also is like because these days people use like mostly people use Retrofit, so they don't understand the underlying sort of technical difficulties. And you mentioned like connection pooling, like just like caching stuff, like gzipping. There's so many crazy things happening under the hood, and that's all very neatly abstracted away by these clients that we use, right? So because the common question people ask is like, why do you even need okHttp, right? And it's because of like okHttp and obviously even like Apache HTTP client, the API, like there's a ton of functionality that you don't even know that's happening, right? And one of the things that you mentioned again, like the implementation for the Speedy protocol, I imagine that's also something that's all like just baked into like these clients. They do that for free, basically.
Yeah, and doing it for free is really a big part of it. Sort of the core approach of okHttp is really strong defaults. So if you get okHttp, we don't want you to have to configure a whole bunch of things to turn on and off features. We want to just say, by default, it's going to be really fast and it's going to be really robust. And so that means that things like turning on transparent gzip, turning on HTTP2, turning on some advanced features for SSL and falling back when SSL fails, making all of those things on and automatic is important so that when you're an application developer, we don't want every single application developer to like write their app and say, okay, I'm connecting from a coffee shop and there's like one of those annoying web pages that's causing my sign-in to fail or my API request to fail. We want that to just like be something that's handled for you. Or
connection retrying or something.
We're doing connection pooling, and connection pooling is a terrible hack that's necessary to be efficient in HTTP 1.1. And so we built a lot of code to make it so that if your connection pools fail, that failure isn't necessarily surfaced to the application layer.
So you mentioned Apache HTTP client was one of them. HTTP URL connection was the other client that was in place, right? So what was the problem with that one?
So HTTP URL connection is great in terms of like when you get an Android device that's Android 4.4 or later, the implementation of HTTP URL connection is okHttp. So okHttp started as a fork of HTTP URL connection, and we took that, we forked it, we added Speedy. And then a year or so later, the new maintainers of the core libraries at Google took okHttp and they updated it in Google's external repo.
Right.
And then the problem with HTTP URL connection, although it's great because it's got all these like nice reliability and performance features, its API is atrocious. So you have problems like you have to call your certain methods in a certain order. And if you don't call them in a certain order, they fail in surprising ways. So you can like set all the request headers, you call some action, and then you can read the response headers, but it's completely implicit. And it's just one object that represents the request, the call, and the response. And so with okHttp, we basically built all of it to support HTTP URL connection. And then later we refactored out separate objects for each of those pieces. And one of the things I'm most proud of in okHttp is that we came across this idea of having a type for the call. Most of the APIs that do these sorts of things, you have a request and a response, and you say like something.execute, and you pass it the request, and it returns you the response. But that action is not instantaneous, and it prevents you from being able to do things like canceling the call or observing what sets of calls are in progress. So okHttp gives you this call object, and all the call serves to do is to give you the active object, because the request is just a value object, the response is just a value object, and the call is the thing that does the work.
Oh, that's fascinating. I almost took that for granted. I didn't quite realize that was happening. But now that I think about it, it is pretty slick.
Yeah. When I was at MyFitnessPal, we used HTTP URL connection heavily in the app at the time. And I'm not sure if it's there anymore, but this was before Retrofit came out. I even remember when Retrofit and okHttp were announced, we had looked at it, but we had such a deep, I guess you could say, connection to URL connection inside the code that we used it. And we actually ended up using a library from someone at GitHub. It was called HTTP request, which was just a bunch of convenience methods wrapped around HTTP URL connection. Because like you said, Jesse, the URL connection was just like this huge God object that had all kinds of stuff, and it made it difficult to work with, and calling the correct methods in the right order was just really painful.
Yeah. And the other thing is that like HTTP URL connection is the subclass of URL connection. And so by default, you have to do this weird thing where say URL.open connection, and then you have to cast it.
Yeah. Oh, yeah. And
then there's a few things that are even weirder. Like suppose you make a request to http://google.com. What that's going to do is it's going to immediately redirect to https://google.com. But because the type is either HTTP URL connection or HTTPS URL connection, the second call doesn't give you access to the certs. And so this is really scary and bad. And then it can also happen in reverse order, where you can get an HTTPS URL connection that doesn't have any S.
Oh, no, yeah. In the world of like the web, this is like very common, right? Like even today, I imagine it happens quite often.
We spent a lot of time on that exact problem at MyFitnessPal.
This is relatively more recent, though. The folks at Square, you released okIO. And I think I have an understanding of why it came about, but maybe you should tell us. We have okHttp, we have Retrofit, which we'll get to, but I guess at this point everyone uses Retrofit, so we want to sort of concentrate more on like the guts and the innards, right? Like the backstory behind it all. So how did okIO come in, and why did okIO come in?
So what is it? Yeah.
So okIO is if you can imagine being asked to build something like okHttp, basically what okHttp does at its core is it gets a socket connection to the network, and that socket is just bytes in and bytes out. And then it needs to basically transform those bytes through a handful of different transformations. One of those transformations is, you want to frame it, which is where you like add the HTTP request and the HTTP headers, and then the body is like the actual data. Another transformation is called chunked transfer encoding. So when you read a response body that's of like some unknown length, the chunk transfer encoding says, here's 100 bytes, you read your 100 bytes. Here's 50 bytes, you read your 50 bytes. And so it's just it's alternating lengths and content. And then there's the gzip transfer. So that just takes the data and it compresses it. And I think those are the core ones. And so when we were working on okHttp, our implementation was just tons and tons of input streams and wrapped input streams. Basically, I got really, really into all the different input streams and the input stream API. And symmetrically, when you post an HTTP request, you have the same output streams. So all of these input streams are just completely unpleasant to work with. Some of this is because of design limitations in how they work, and some of this is just like bugs in the APIs.
And this is the native input stream, right? You mean
in
like
Java IO
native,
input stream. So like one example is that suppose you're doing HTTP and you want to read the request lines and some headers. Those are strings. And so you want to take your input stream, wrap it in an input stream reader, read those lines, and then immediately, as soon as you've read the headers, you need to go back into binary mode because you might be like streaming a bitmap or something. And so it's completely awkward to go from text to binary and back. And you have to make sure if you're in like switching these modes, you don't over buffer too much data. And so all of the okHttp code up until 2 years ago was just disgusting because we're just like working around all of these different input stream problems where we say, don't overread too much data, don't underread too much data. And there was one more problem that really just pushed me over the edge. So if you're doing HTTP2, the way that okHttp does HTTP2 is it has a dedicated thread that reads all the data from the server. So this thread is actively reading everything that the server sends. And the server is, because HTTP2 has potentially many different requests and responses interleaved with one another, this thread is basically reading data off the network and then putting it in the appropriate buckets for the various application threads to read. So you're making a request for like your profile picture and your customer name and your tweet or something. It's going to take those things and multiplex them, basically. So there's this thread and it's constantly reading data from the network. And with HTTP2, we had this problem, which is that we needed to figure out a place to put the data that we'd read from the network. And this turns out to be a really hard problem. We just allocate a 64 kilobyte array, so 64 kilobyte byte array for every HTTP connection. And so if you're, reading an image, we read it 64 kilobytes at a time. And if ever that array gets full, then your entire application stalls until the application reads those bytes out.
Oh, because it's blocking at that point. Okay.
So what we needed, and the alternative is like, okay, well, we can give it a 128 kilobyte buffer, but at some point it's just like every request is just allocating tons and tons of memory. So what we decided that we needed was a resizable buffer. So we could say you make a request and initially you get, 2 kilobytes of memory. But as we pour more and more data in there, we're going to allocate more and fill it up. And so we end up with like a producer-consumer thing where the network thread is reading data from the server and putting it in a buffer. And then the application thread is reading that data out. So you're like downloading, you're downloading a 1 megabyte image. And so the network thread is writing bytes to the top of the buffer and your thread is reading bytes from the bottom. And so we needed that technology.
Okay.
So okIO is a ton of code wrapped around a resizable buffer. That's the core idea is let's have a resizable buffer. And once you have a resizable buffer, a lot of other problems like sort of disappear. So we built the resizable buffer and that's called okIO.buffer.
Okay.
And then we started using that for all of our other streams. So we use that for the framing and the gzipping and the chunked encoding. And so everything now is just like one buffer. And once we like found this abstraction, all of our other problems just like started to disappear. And so we found that like we deleted a whole bunch of code from okHttp because we were making it very easy to do I/O, whereas previously everything was a bear. So okIO was just like the I/O layer from okHttp ripped out and made into a standalone project.
And do you see other applications of okIO, like beyond it being used in okHttp? I mean, do you folks use it for like a whole bunch of other things?
So what we did with okIO is we started with just this buffer thing, and we created two more classes, buffered sync and buffered source. And so a buffered sync is just a place where you can write bytes and strings and integers and things.
Right.
And a buffered source is the place where you can read those things, write and read. And so we use okIO anywhere that any other application or whatever would use input streams and layer input streams in painful ways. What we built all our libraries on okIO's abstractions. And just like how we got to delete a ton of code in okHttp, we got to delete a ton of code in Wire, which is our protocol buffers library, and Moshi, which is our JSON library.
It's all coming full circle now.
It's like once we have this like technology, it's like, oh, building protocol buffers is actually really easy once you have like the right abstractions. If you look at Google's protocol buffers code, it's just like, oh, it's like wrestling with an alligator because it's trying to get the input stream to do what it wants. Whereas with us, it's just like, oh, you want to read 4 bytes from the network? That's like one call and you don't have to do any work.
I agree. Yeah. I had to deal with the protocol buffers last year, and that was a painful experience.
So at some point, like the NIO thing came in, right? Like non-blocking IO, that was introduced at some point in like natively in Java.
Java 1.4.
1.4?
Yeah.
Okay. Wow. And so did that at any point influence how okIO was? Because I imagine, I haven't worked like at that low level detail, but I imagine like the introduction of like channels and buffers also made it easy. So at that point, was it just like swapping out like the parts in okIO to work with channels and buffers in a more efficient way? Or like how did that work?
So okIO gets along really well with Java IO, because it takes, input streams and it puts this nice abstraction over them. It doesn't work at all with NIO. And I probably get, pitchforks and out for me, but I really think NIO is a piece of junk and you shouldn't use it.
Wow.
I think that as far as APIs go, and I say this a little bit honestly, having like, I was responsible for the implementation in Android for a little while. I think that NIO is a very good idea, but it's a very bad implementation of it. The idea is you're writing a massively concurrent web server and you have, let's say, 10,000 concurrent requests at a time. Every thread that's in your server is consuming, 1 or 2 megabytes of memory.
Right.
And so that's a lot of memory overhead. And there's potentially also a lot of context switching between those threads. So NIO says, instead of having 1 thread per socket, let's have a small pool of threads, and we'll have a way that the threads can do IO without blocking. The problem is that NIO was one of these like bad Java cross-platform abstractions where they were like, okay, what does this non-blocking IO API look like on Solaris? What does the non-blocking IO API look like on Linux? What does it look like on Windows? And NIO has like a bunch of problems where it works well enough for each of these things,
but it doesn't work really well with one specific. Because at that point it was designed by standards, I guess.
Yeah, and there is a really good library called Netty that takes NIO and makes it reasonable, but it's still extremely complicated because a lot of your code is working very hard to basically avoid allocating threads. And NIO is all about reducing the number of threads that you have in use. With Android apps, we generally don't have hundreds of threads all simultaneously hammering the network. And generally, because our cell phone radios are not particularly like high bandwidth, you don't have a gigabit connection on your cell phone. You don't ever even have the ability to saturate the network like you could with NIO. So NIO is fantastic and it's worth the pain when you're doing a highly concurrent web server. But okIO is like, if you're only serving a single user or you're serving a single application, the performance is actually better. There's a trade-off where you basically need to get past some high number of threads before NIO becomes better performance. Yeah. And then the other thing that makes this complicated is that Java's threading model and its heavyweight threads is wonderful because it's easy to program in. You just write code top to bottom and the right thing happens. But we're seeing a lot of reactive programming now, and also things like coroutines or go-routines in Go, which take a completely different approach. And I think that the future is not going to be hundreds of callbacks. I think the future is going to be things like reactive streams and straightforward code, like top to bottom code that reads an entire document, and then magic in the IO layer that makes it so that you're not necessarily one-to-one between a stream and a thread.
So we've talked a little bit about okHttp, okIO, some of the underpinnings, but I think everyone kind of comes to find okHttp and okIO from Retrofit. And I was wondering if we could talk a little bit about Retrofit in general and how it differs from okHttp, or where it fits in to Retrofit, and how maybe Retrofit came to be.
So, Kaushik and I were just talking about this. If you're looking for a fun exercise, go to the Retrofit GitHub page and look through the commits and scroll down to, page 35 of the commits, from 2012.
This is crazy. Yeah. This
and
is really crazy.
if you look at Retrofit in 2012, you'll see that it was a completely different project. It was kind of Square's Guava for Android. And there's a bunch of ridiculous things in there. Like at one point, Retrofit had a shake detector in it. So if you shake your phone, the Retrofit library has a feature to say, your phone is shaking.
Yeah. And I actually saw the Java class for this. Like, I couldn't believe it. The Retrofit that we think about today is just so different from the Retrofit.
Yeah. It was like a grab bag of things for Android. And there's a handful of Square libraries. About 3-ish years ago, we said, let's do some Android open source. Mm-hmm. And what we started with was, let's just take things that are in this Retrofit common area and extract them into their own standalone projects. So we have a project called Seismic, which is the shake detector from Android, or from Retrofit. We have a project called Tape, which is the persistent queue from Retrofit. And we pulled all these things out, and it was wonderful having these things as standalone and not having this sort of grab bag of random things. And once we pulled everything out, there was one class left, which was called REST Adapter. And REST Adapter, through a lot of work on Jake's part, grew up into be what we think of as Retrofit now.
This is so crazy. I even remember the initial versions of Retrofit, even the Retrofit that was exposed. I remember the REST Adapter was a very primary call, right? Essentially that was how we would get Retrofit going. Yeah.
And so in Retrofit 2, we renamed REST Adapter to Retrofit.
Right.
But that never made sense 3 years ago because Retrofit wasn't the REST Adapter. Retrofit was that was the stuff.
That was the grab bag.
That was the grab bag. Yeah. And so in early versions of Retrofit, only in Retrofit 2 does it have an okHttp dependency. If you use Retrofit 1.8 or 1.9 or whatever, I think 1.8 is the last one, it will plug into HTTP rail connection or Apache HTTP or okHttp. And so the consequence of that is that there's a lot of work that Retrofit was doing that we've since moved to okHttp, and we've been pretty liberal in moving things from Retrofit into okHttp. So originally, if you wanted to do something like submit an HTML form with an Android app, do a form encoding HTTP post. Yeah. That code lived in Retrofit, and okHttp didn't know anything about that feature, and we promoted that from Retrofit into okHttp. Another example is we never used to have a request and response type in okHttp because it used to be that URL connection thing. Oh, those lived in Retrofit, and it had a headers type and a body type.
Right.
So everything was in Retrofit, and basically I kept stealing things from Retrofit and putting them into okHttp. And what eventually happened was Retrofit and okHttp, as of Retrofit 1.8 and okHttp 2.5 or something, they were gross in terms of how much duplication there was, because we took all these HTTP primitives that Retrofit was doing so that it could layer them on any HTTP client.
Right. So massaging them into the different clients of your choice.
And so okHttp took over a lot of these responsibilities, and Retrofit now really is just the REST Adapter. All it knows how to do is take an interface and turn it into a bunch of calls into okHttp. And so with Retrofit 2, we deleted so much code and just put all the responsibility in the HTTP layer.
Interesting.
And I would like to apologize to everybody who is upgrading from Retrofit 1.8 to Retrofit 2. That is very sophisticated and difficult migration that you should make.
Yeah, I remember. So like at one of my colleagues at Instacart, so like we're hot on the heels of like trying to move from Retrofit 1 to 2. Like we're trying to push, and it is a little tricky. It isn't, because obviously, and I mean, rightfully, since like it was a major version upgrade, like I imagine there are breaking APIs, obviously. So it isn't something that you can just like flip a version and just like meddle a little. There are like some things that have fundamentally changed, right?
Yes.
But some of the advantages that you get with Retrofit 2, I think it's totally worth it.
Yes. The features I really like are, because it depends on okHttp for everything, there's no longer this duplication of models.
Right.
And then if you look at the Retrofit 2 code, it's like actually relatively straightforward. There's like a couple of interesting magic classes that know how to use Java annotations.
Right.
But for the most part, it's just like all Retrofit does is it takes your Java interface, it reads the annotations, and it figures out how to make HTTP calls from those.
That's pretty cool. And so at some point, Moshi came along as well, right, as a JSON parser. And I know, so JSON is traditionally what most folks use for their JSON parsing needs. So how did Moshi come about? Was that also like one of these things where you had like a lot of sort of JSON being abstract, and then you decided, actually, let's just like abstract this away because I probably want to use it in okHttp. I want to use it in different places.
A little bit.
Okay.
So I'm one of the JSON maintainers. I was working on JSON.
Yeah, that's the other crazy thing. So like JSON is like, I mean, I know you were like very keen. There were a couple of people, Inderjeet and Joel at Google, who designed and built JSON, and it has like a bunch of really nice things about it. And I joined later when I was working on JSON parsing in Android because I built a much faster JSON parser. Mm-hmm. And so I worked with them to take Android's fast JSON parser and put it into JSON. And so I was working with them, and we did JSON 2.0, and that was a really big deal, and I was really proud of that. And what ended up happening was I transitioned to work on the server on the cache team. And we use JSON so much on our service because we're constantly talking to the web. We've got all these different clients. And if you want to use JSON effectively, there's a lot of work you may have to do. So for example, JSON by default doesn't default its date formatting to something I think is reasonable. Yeah. If you use JSON and you just configure it out of the box, you say new JSON, what you're going to get is a date formatter that's going to use your local time zone. So if you use JSON in California and you're talking to a server in New York, your times are going to get totally broken, and it makes no sense, and it's completely terrible. And the thing that's really terrible about this is you only find out about it when you're adding that server in New York after you've been running in Los Angeles for 5 years. Right. So I think that there's like a handful of small little problems in JSON that are very difficult to fix, because if we want to fix them, we end up breaking wire format compatibility with previous versions of JSON. We can't just like change JSON state format to support anything. Right.
Because, there's always a producer and a consumer.
It's interesting because I remember when I was working in Wedding Party, this was exactly one of the problems that we run into, because like it's an app for weddings, right? And so essentially the event details, like that's all parsed. Like it's again a very like a REST server. We send date formats down, and if the event details like are different, like people will get mad. And like that was like a big problem we had to solve, because like you see the time, you see like, okay, it's like 6 p.m. like Eastern time, but then when you actually land in California, it's a different time, and then people are like, what? Like you do not want to mess wedding event details.
Dates are difficult enough without your JSON parser, trolling you. So we've got a handful of different things that I was thinking about, kind of like what if I was imagining. So one other example is that if you use JSON, there's sort of two different models. There's the you've got your sort of object model. That's where you have your, like, if it's wedding party, that's where you have like your wedding and your guest classes. Mm-hmm. And then JSON also has these models called JSON object and JSON array. Mm-hmm. And one thing I was frustrated with is that JSON object and JSON array are almost identical or interchangeable to Java's map and Java's array list. They're pretty interchangeable. And then there are other weird, like tricky types like JSON has a number class, JSON primitive. And so if you have a string, it's wrapped up in a JSON primitive. And so if you want to get at that, it's a little bit complicated.
Right.
So what we did with Moshi is I said, what would it look like if we built JSON now knowing all the things that we learned along the way with version 1 and version 2. And so Moshi, to me, is a spiritual successor to JSON version 2. Mm-hmm. And I'm going to be using Moshi for all the new projects that I write.
Okay.
But that said, JSON development is ongoing because the install base of JSON is just humongous. It's like probably one of the most popular libraries around. It's also interesting, JSON is a project on GitHub that's run by Google. And there are no Googlers who are actively maintaining JSON anymore. So really? If you work at Google, you should shut us down. And that's just like a historical accident. And it's a weird thing about open source, where you can have a handful of people who open source something at your company, and they can leave and continue to use your brand name, years later and screw up your dates.
That's also like one of the beautiful things in terms of like the project, right? Because it keeps living on and can,
yes.
Versus it just being shut down, or then it's like, or development just halting altogether on the library.
Definitely.
Right?
Definitely.
So that's pretty cool. You mentioned like, so Moshi is something that everyone is, if I know that you're going to be maintaining Moshi, then I'll feel more, I wouldn't be that hesitant to add it for new projects. So that's a good thing to know.
Moshi's, like, one of our design goals with Moshi was, what's the smallest amount of code we could write to have a good enough JSON library? And it's like very, very minimalist in terms of like how much code there is. There's type adapters and there's a Moshi class and there's a couple of annotations and that's it. So it's pretty easy.
Yeah, and even if you look at, I guess, like the GitHub page on Moshi, it shows some of the examples and it is pretty neat, and it's like the way it's implemented.
Need to improve those GitHub pages to make it like much better marketing. I think that kind of stuff is a big deal.
Yeah.
I screwed up with the darn coffee maker with Dagger.
I didn't want to bring it up out of respect, but
that was.
I will say that I have met more than one person who's like, what is like a thermos? I don't understand. Is that like a Java thing?
No, I was like listening to podcasts or something, and they're talking about how clever the coffee makers are.
Yeah.
The day before I have to write my Dagger talk, and it's like, thermosiphons are super cool.
Yeah.
It's a pump and a heater.
Yeah. So this has been amazing, Jesse. Thank you so much. A lot of great war stories there, and also like some interesting insights into libraries that we probably use almost every single day. Yeah. Any parting words for our good listeners before we wind down?
I think I would just like absolutely love it if people do check out okIO. I think that just there's like a handful of little things that you do that are like way easier with it. There's a class called ByteString, which is just like string, but it's for data rather than for text. Oh. And if you use ByteString, it solves a ton of your problems. I use this method called bytestring.base64 and bytestring.hex like 5 times a day. And it's like, if I have some opaque thing and I want to like have a model for it, I just use that. And I'm like shocked and delighted that there's nothing in the Java standard library that lets you model an immutable sequence of bytes. You can imagine how terrible it would be if we had like char array, but not string.
Right.
But we have byte array, but not byte string. And so okIO has that. That would be the thing I would say. Go home and take a look at that.
Perfect. And if folks want to reach out to you, Jesse, what's the best way we can?
I'm Jake Wharton on Twitter.
If you have bugs on any of the libraries, just like, and also like give us Jake's emails.
Yeah, exactly.
Just like
I am Jesse Wilson on Twitter. Spelled like it sounds.
Perfect. And if folks want to reach out to you, Don, how do they do that?
You just find me on Twitter at Don Felker.
All right. And I am Kaushik Gopal on Twitter, and our Twitter handle is FragmentedCast. So you can send questions, feedback, thoughts, all over there. Show notes for this episode, and we'll make sure to add like all the interesting links and tidbits that Jesse mentioned in this episode out there. It'll be fragmentedpodcast.com/episodes/46. You'll find the show notes there. And thank you all for listening, and we will catch you next week. We want to thank Sarah and Bryn especially for this episode. They were kind enough to host both Jesse and me in our wonderful studio here. So a big shout out to those folks.
Thank you very much for that.
Thanks again, Jesse.
Thank you.
Once again, we want to thank our sponsor for this episode, Rollbar. With Rollbar, you get the context, insights, and control you need to find and fix bugs faster. Go to rollbar.com/fragmented to get the Bootstrap plan for free for 90 days, which includes 300,000 errors tracked for free.